Hello students, in this video we will see Mealy to Moore machine conversions. Let's start. For any given Mealy machine, let's say this is given Mealy machine, it is defined by the 6 tuples. We are already familiar with this all tuples. I am not repeating here. I'll just explain lambda is a machine function, and in Mealy machine it is a function of state and input symbol, or in short we can say output is associated with the transition. So before going to start with the conversion, we understand some concept. Let's take this as one example. This is given Mealy machine. This is not for any problem. It's I have taken one example to understand the conversion part. So let's focus on the state P. As you can say, there is a state P, and there are two transitions coming to the state P. One is on input 1 with output S, and one is on input 0 with output no. So when we try to convert this thing into the Moore machine, the first challenge is what? In Moore machine, yeah, output is associated with the state. It is not with the transition. And if you try to associate the output here to the state, it's very difficult to give two different output to the same state, right? As there are two different output is coming to this state, as you can see, one is S and one is no. So how we handle this challenge? So what we can do, we can split the state P into number of output symbols. As you can see here, P is splitted into the output N, and one is another state is P with output S, and according to the output the transition is also distinct, it is separated, right? So same concept we are using while converting Mealy to Moore machine. For every state, we are taking a combination. Let's say there are state n, and there are m output symbols. So in the resultant Moore machine we will have m into n states. So for every state we are taking combination with the output symbols. So let's see how we convert this Mealy machine into Moore. So let's say this is M2 is a equivalent Moore machine, and as we know, in Moore machine the state is going to change. So that's why it is given by the Q dash. We will see how we find the Q dash, and all the related dependent terms on the state is also going to change, which is delta state function, and lambda is a machine function. So let's see how we find the q dash. Q dash is nothing but it is a combination of state with the output symbols. As I said you, if there are n output symbols, so each state is divided into the n symbols. One example we have already seen, here is the state P, and we divided that, or we splitted the state into two output, because there are two output symbols, it is there are two states, right? Lambda dash, finding the machine function is very simple, because here we have a state with the output symbol itself. As you can see, here is a p comma n and p comma y. So the caption given to that state, that is b is the output symbol, is nothing but the machine function of that state. Okay, because in Moore machine output is associated with the state. So how we find out the output, associated output with the state? That caption itself is the output, right? So for getting the delta dash, we will take one example. So from that example, it is very clear that how we find the state function. So let's take this is example. Already we have solved this example in class. Here, this is a Mealy machine which accepts the strings over 1 comma 0, which is ended with either 1 1 or 0 0, right? So we have to convert this Mealy machine into Moore machine. This is a given state function for this, and this is given machine function for this. So to understand the delta, like how we convert, for let's start with the q dash first. So as we know, there are two output symbols, s and no, and there are three states, q0, q1, q2. So in the resultant Moore machine, we are having the q dash like this. As we know, every state is splitted into the number of output symbols. So one example is given, q0 with n, q0 with y. Like this we can add other states like q1 comma n, q1 comma y. So I have just added two states, and you understand for every state we have to use the output symbols. Now how we find the delta dash and lambda dash? So finding delta dash and lambda dash is we will see. Finding the machine function is very simple. These are the states. I already told you every state is having the output symbol now. As you can see here, Q0N, Q0Y, Q1N, Q1Y, Q2N, Q2Y. So every state is splitted according to the output symbol N and Y. So what is the machine function of this state is nothing but the output symbol associated with that state. So as you can see, Q0 comma N, output is N here. So machine function is N for this. Okay. Similarly, you can find for all the states N, Y, then N again. Here it is output is S. Here output is no, and here output is S. So we are getting the machine function. It's very simple. You just look at the state and find out the output symbol. Now finding the state function, we will take the help of this two function. One is a state function and one is a machine function of given Mealy machine. And from this two table, it's very simple. So let's take. I'll tell you one entry how to find out the machine this delta dash. So let's look at the state is Q0 and output symbol is N. But we are not looking at the output symbol. We are looking at just what is the state Q0. And on input symbol 0, we have to find out the entry of this delta dash, right? So how we find out? Just look at the state function delta. So and find out what is the next state on Q0 comma 0. So on Q0 on 0, next state is Q1, right? So we will take this next state from the state function of Mealy machine. So we are getting the it is Q1, right? And we know now state is not only Q1, we have to find out the caption of that output caption of that state as well, because as you can see the new Q dash is having all the state in this form, right? Okay, now to find out the caption of the state, let's look at the machine function and same entry here. Just find out Q0 on input 0. What is the next? What is the output symbol, which is N? So we just copy here Q1 comma N. So it's very simple. From state Q0 on N, on input symbol 0, next state is Q1 comma N. Similarly, you can find out here what is the next state on input symbol 1. So same, we will refer the state function Q2 and the corresponding output is N. So we are getting the next state here Q2 comma N. Okay. Similarly, you can find for all remaining entries. I'll tell you one way. If for Q0N and Q0Y, we are getting the same transitions. You also try, you are getting the same state here. So once you find out for Q0, it is same for all Q0 with different output symbol. In short, this output symbol is not making any role while finding the delta dash, right? So if you try for the Q0, here also we are looking Q0 on 0. So same entry we are getting Q1 comma N. Okay. So I'm not repeating here. Let's start with Q1 N. We are not taking this symbol into consideration. Q1 on 0. Just check Q1 on 0. State is Q1 and output is Y. So I'll just directly write here Q1 Y, right? So, and in this way, we can find out the next state, or you can say it is a delta dash. Okay. And with the help of this, you can complete all the entries. Q1 on 1, you can find it is Q2 and symbol is N. So, it is Q2 comma N. Okay. And for next state, no need to find out same transition or same entries. You can copy there, right? Similarly for this Q2 comma 0, Q1 N, and Q2 on 1, it is Q2 Y. Okay. So here also I'll just complete this. It's very difficult. And same state you will find here also. So mathematically now I'll explain the what is delta dash actually. So you can see here delta dash is nothing but it is what is the next, suppose this is a state q comma b, and on input symbol a, how you will find out the next state on q comma a. So next state is given by this, and what is the output symbol associated with this transition is given by lambda. So one example I'll just explain. Same thing I have done here. Q0 on n, this is a state and input is 0. So how we find the next state here? So we have just taken the next state using this Q0 and the input, and we also refer the machine function on the same Q0 on 0, and we are getting the this thing. As you can see, same we have written here. Okay, so just looking at the transition table, you can find out delta dash, and then instead of like looking at this this all this equation. Okay, so now we have completed the transition table. So as you can say, this is a transition table. As I'll tell you, there are two, we are getting the two initial states here, Q0N and Q0Y. So no need to consider two. You can discard any one of them, either Q0 comma N or Q0 comma Y. It will not make any difference either, or you can choose for the constructing the transition graph. Okay, and these are the states, and this is a final solution as you can see, and you can remove the one of the state from this what we can say transition graph, and finally we are getting q0n is the initial state, and all these are the uh, q2 and all these states already we have seen. Now let's see, is it equivalent to the given Mealy machine or not. As we know, given Mealy machine is accepting all the strings ending with 1 1 or 0 0. So let's take one example, 1 0 1 1. This is valid string for our problem statement. So let's simulate the string from state q0. I'm not using the complete this caption here. I'm just writing q0 and output is n, right? So here you can see this your this thing is indicating what is the output of that state. Okay, or you can separately write down here n on the top of state, or you can refer the output from that state itself. So from q0 output is n, and input is 1, so it is going to the state q2, right? Then from q2 I'm not writing now output every time. I will just keep the track which state is q2 n we have. From q2 n there is a input again 0. So on input 0, it is where it is going. It is going to the q1 with output n. So again I'm not writing output here. We are just or you can write here to avoid the confusion. Q1n, the next input is what? Which is 1. Q1n on input 1, it is going to the Q2. Again output is n here. And from Q2 the input is last, this is the last symbol from the input, which is going to the next state Q2 with output y. So y means it is accepted, right? And as you can see, it accepted the string which is as per our problem statement ending with 1 1 or ending with 0 0, right? So you can see here from this diagram also, this accepts all the strings over 1 comma 0 which is ended with 1 1 and 0 0, right? Thank you.